Hi guys, this is lesson 8.4. I can classify triangles. Today we're going to name triangles based on their sides and angles. The first type of triangle we're going to talk about is called an isosceles triangle. When I think of an isosceles triangle, I think of an ice cream cone. The cone is in the shape of an isosceles triangle. An isosceles triangle has two sides that are exactly the same length. Another type of triangle is an equilateral triangle. When I hear the word equilateral, I can imagine a ladder. And a ladder has equally spaced steps on it. An equilateral triangle has three sides that are exactly the same length, and all three angles are the same measurement, which would be 60 degrees. The last type is a sneaky scalene triangle. And a scalene triangle is sneaky because none of its sides are the same length. This triangle is a scalene because each side is a different length. That makes it sneaky. We've also learned that you can name a triangle by its angles. An acute triangle has three acute angles, which means the angles are less than 90 degrees. A right triangle has one right angle and is usually labeled with a square. An obtuse triangle has one obtuse angle, so that one angle is greater than 90 degrees. We can put together what we know about triangle angles and the length of the sides of a triangle, and we can give each triangle two names. So let's take a look. This triangle is named XYZ. So I'm going to name it. I'm going to name it by each vertice. Here's a vertice, here's a vertice, here's a vertice. This triangle could be XYZ or ZXY or YZX. Now we're going to name each angle, acute, right, or obtuse. Angle X right here is clearly less than 90 degrees. So that would make angle X acute. Angle Y right here. Well, angle Y is clearly greater than 90 degrees. That means angle Y has to be obtuse. Finally, let's look at angle Z. Angle Z is pretty tiny. It's clearly smaller than 90 degrees. That would mean it is acute. Let's give this triangle two names. First of all, I see that it has a 90-degree angle. So this could be named a right triangle if I'm naming it by its angles. Now, looking at the length of our sides, it looks to me like two sides are the same length, and one side is really long. If we have exactly two sides the same length, then this would be an isosceles. So we would call this a right isosceles triangle. Let's look at this triangle. If I name it by its angles, I can see all three angles are clearly less than 90 degrees, making this an acute triangle. I also can tell that this side is longer than this one, and it's also the same length as this side. So clearly we have two equal sides. If I turn this triangle upside down, it would make an ice cream cone. So here is my ice cream cone upside down. So I know it has to be an isosceles. So the name of this triangle is an acute isosceles triangle. Let's look at this one. Oh, okay, if I look at the angle, I can clearly see this one is greater than 90 degrees. This has to be an obtuse triangle. Let's look at the length of our sides. Each side looks to be a different length. Seems pretty sneaky to me. So this must be a scalene. So this would be an obtuse scalene triangle. Sneaky scalene. Watch out for those. All right, now we're going to use figure A, B, C, D below. We're going to draw a line segment from point B to point D. Okay. Whoops, that was kind of crooked. Let me try again. From B to D. Now we're going to name and classify the triangles formed. Well, first, let's go ahead and name this one right here. This is triangle DAB, or DAB. And what kind is it? Well, let me get my marks out of the way so I can really look at it. Okay, so this looks to me like it's greater than 90 degrees, so that would have to be an obtuse. And the length of our sides, they look like three different ones to me. So I think this is an obtuse scalene. Now let's look at our second one here. Triangle DCB, triangle DCB. And again, it looks to me like we've got an obtuse angle right there. So it's an obtuse. And again, it looks like a sneaky scalene because all three sides are clearly different lengths. So they are both obtuse scalene triangles.